All right, let's talk about applied machine learning. We're going to go way beyond just building a model in a notebook. We're diving into what it actually takes to get these things working in the real world, from a simple prototype all the way to a full-blown production system that might be serving millions of people. And really, this quote is the whole point. The best people in this field don't just build models, they make them work in production. See, it's not about getting the highest accuracy score in some clean, perfect lab setting. It's about building systems that are reliable, that can scale, and that actually move the needle for a business. That's the leap from theory to reality. So, here's our game plan for today. We'll start with the fundamentals, the building blocks. That's models and features. Then we'll get into the tough part, going from a notebook to production. After that, we'll see how to test things out in the wild, tackle the absolute necessity of data quality, and then wrap it all up with what we're calling the modern ML mindset. Okay, let's jump into section 1, models and features. You can't build a sturdy house on a shaky foundation, right? It's the exact same idea here. In machine learning, your fundamental materials are the models you pick and the data you feed them. So let's get this right from the start. First thing you have to realize is just how big the ML toolbox is. I mean, look at this. Are you trying to predict a number, like a house price? That's a regression problem. Trying to make a yes-no decision, like is this email spam? Well, that's classification. Forecasting sales for the next quarter? You're in time series territory. Just knowing which category of tool to reach for is a huge first step. So you've picked a model, great, but how do you know if it's any good? Your choice of metric literally defines what good means. If you're predicting stock prices, you want to minimize your error, so you'll look at something like mean squared error. But if you're building a search engine, the order of the results is everything. That's where a metric like NDCG comes in, which is designed specifically to measure the quality of a ranked list. Choosing the right metric makes sure you're actually solving the right problem. So how do you actually pick the right model? Well, it's not guesswork, it's a process. You always start with a simple baseline, something easy that gives you a number to beat. Then you bring in the heavy hitters, the more complex models, and see how they stack up. Once you've found a promising candidate, then you can spend your time tuning and tweaking it to squeeze out every last bit of performance. It's a methodical process. And this brings us to a massive, massive point. You could spend weeks trying to tune a model, but a lot of the time, the biggest improvements come from a totally different place. This quote is perfect because it shifts our focus away from the fancy algorithms and toward the thing they eat, the data. Better features, that's almost always the key. This is really where the art and science of ML meet. Feature engineering is all about transforming raw data into powerful signals that your model can actually understand. This could be anything from turning raw text into numbers using embeddings, to scaling your features so they're on an even playing field, to even simplifying the problem using something like PCA. Trust me, better features will beat a bigger model almost every time. Now, when you're working in a real production environment, you can't have everyone just creating features in their own little notebooks. It would be chaos. That's where a feature store comes in. Just think of it like a central library for all of your well-defined, ready-to-use features. It makes sure everyone is using the exact same logic, whether they're training a model or making a prediction, which is crucial for consistency and reusability. Okay, on to section 2. So you've got this great model, it's performing well in your notebook. Now comes the hard part, taking it out of that clean, safe environment and plugging into the messy, chaotic real world. This is the journey from a prototype to a real product. Once your model is out there, it's typically going to work in one of two ways. The first is batch inference. This is for jobs that aren't time-sensitive, like generating monthly billing predictions. You just run a big job once a day or once a month. The other way is real-time inference, where every millisecond counts. Think fraud detection on a credit card swipe, or a recommendation engine that has to serve an ad the instant you load a page. This right here is probably the most important concept in production ML. It's not a straight line, it's a circle. It's a continuous loop. You don't just deploy a model and then walk away. You have to constantly monitor how it's doing because the world changes, data patterns drift, and that feedback loop tells you exactly when it's time to go back to the beginning, retrain your model on new data, and keep the whole system healthy. And of course, managing this whole life cycle isn't easy. It requires a whole suite of powerful tools, what people call an MLOps stack. You'll need tools for serving predictions, for running those big batch jobs, for monitoring performance, and for automating all the deployment stuff. This is the engineering scaffolding that turns a simple project into a robust, production-grade system. So, your model is live. That's a huge milestone. But here's the next big question. How do you know if it's actually helping? Sure, your offline metrics looked good, but what about real-world impact? That's where we get into experimentation. So how do you prove that your new recommendation model is actually better than the old one? You run an A/B test. It's the gold standard for a reason. It's basically the scientific method for product development. You come up with a hypothesis, you split your users into groups, and you show the new model to one group and the old model to the other. By measuring the difference, you can say with actual statistical confidence whether you've made things better. It takes all the guesswork out of it. We've kind of danced around this a few times, but this section is all about what might be the single most important part of applied ML: data quality. Because at the end of the day, no matter how clever your model is, garbage in will always, always mean garbage out. I really want you to let this quote sink in. It is one of the fundamental laws of our field. You can have the biggest, most state-of-the-art neural network in the world, but if you feed it garbage data, your results are going to be garbage. Bad data will sabotage a good model every single time. The key here is to be proactive. This is just a sample, but for most common data problems, there are well-known solutions. Got missing data? You can use smart ways to fill it in. Got crazy outliers? There are techniques to handle them. And for that sneaky problem of data drift, where user behavior just slowly changes over time, that's what monitoring and retraining is for. You have to anticipate these issues before they poison your results. All right, for our final section, let's zoom out. We've hit on models, data, engineering, testing. Now let's talk about the mindset that pulls all of these skills together and turns you into a top-tier professional. You hear these titles all the time, right? Data scientist, machine learning engineer. And yeah, there's a ton of overlap, but this really gets at the core difference in focus. The data scientist is often more about analysis, prototyping models, and discovery. The ML engineer is the one who takes that discovery and builds the robust, scalable production system around it. So, what really separates someone good from someone who's truly great in this field? It's having this blend of 4 different perspectives. Of course, you have to be data-driven, but that's table stakes. You also have to be business-aware, so you know you're solving a problem that matters. You've got to be product-oriented, always thinking about the end user. And finally, you need that solid engineering focus to build things that don't fall over. It's the combination of all 4 that really works. And this quote just brings it all home, right back to our very first idea. The end goal isn't a saved model file on your computer. The real skill, the thing that provides real value, is successfully weaving that intelligence into a product that people actually use. So I'll just leave you with this one final question to think about. Shifting your mindset from I build models to I build intelligent products, well, that's the secret sauce. That's the key to making a real impact. Thanks for tuning in.